Missile internal AC. Water flow satisfactory.
Jumping LS2.
Minus 2 minutes. Mark.
Switching range safety beacon and commands to internal.
Minus 150.
Full stop. Telemetering systems to ready.
145.
Gas telecom switch to arm. Online on.
Engine press delay on engine test. Missile AC, internal DC.
135.
The countdown at Cape Canaveral is nearing the instant of flight for Project Mercury Atlas. This will be an unmanned test flight, a prelude to the historic flights to come in Project Mercury, America's man in space program. I'm Phil Culbertson, Mercury project engineer at Convair Astronautics in San Diego, California, where the Atlas is produced. In future Mercury flights, the Atlas will boost the free world's first manned capsule into orbit. The life of the astronaut riding in the capsule will depend upon the proper performance of each vehicle system. To ensure the astronaut's safety and the success of the Man in Space project, the Air Force has established the Mercury Quality Assurance Program. It is designed to maintain the highest possible quality standards for all parts, components, and systems destined for Mercury vehicles. At the McDonnell Aircraft Corporation, where the Mercury capsules are produced, and here at Astronautics, high standards are already maintained for component selection, assembly, and installation. But the Air Force has requested that additional efforts be made to provide the highest possible quality components and workmanship for the program. The success of Project Mercury, and in fact the very lives of the astronauts, rests with all of us, vendors, subcontractors, and associate contractors, who are involved in any way with Mercury hardware. The highest possible reliability is the goal of the Mercury Quality Assurance Program. To achieve this maximum reliability requires many things. First, it requires that we understand our jobs and have the skill to do them properly. It requires that we have the correct materials and tools to work with. And it requires that we set up the proper balance of test and inspection. But with all of these things, we can still fall beneath our reliability goal unless each one of us recognizes the importance of his work. The man making the television set, for instance, knows that if it fails, it will be inconvenient, but it can be set out for repairs. The man making a part for a Mercury system knows that it must not fail. This circuit board, for instance, looks insignificant. The person who builds it may feel very remote from the booster on the complex and the man sitting in its nose. But this board is part of the logic circuit of the Atlas Mercury autopilot, and failure of any part of it could cause loss of the booster. The job of each of us, whether it's in design, test, fabrication, or inspection, is similarly critical to the Mercury mission. The multi-phase quality assurance program is aimed toward keeping each of us aware of his role in the Mercury program. This distinctive Mercury decal, which is applied to major components selected for Mercury vehicles, was created for one phase of the program. The symbol is the astronomical symbol for the planet Mercury. The R in the center is the seal of our reliability organization and is used to emphasize the importance of reliability in Project Mercury. A major aspect of the quality assurance program is the selection of parts and components. All major components which are common to Atlas missiles and Mercury boosters, such as these booster engine servo cylinders, are specially selected. Selected units must first meet exacting standards established for Atlas, but additionally, each must have no history of rework or repair, must perform well within acceptable tolerances, and must have had no excessive operating time. Major components and systems receive the decal as soon as they are identified as being destined for a Mercury vehicle. But before receiving decals, they must first pass rigid inspections. For instance, this propulsion system, produced by Rocketdyne, already has been tentatively approved for Mercury on the basis of its performance and manufacturing history. But now it is subjected to further inspections. In this test cell, the sustainer, booster, and vernier engines undergo pneumatic, hydraulic, and electrical checkouts. oil is removed from hydraulic lines for examination under a microscope. The oil is drawn through a special filter paper, and the filter is studied for traces of metal filings and dirt. If contaminants are found, the system is rejected. After a thorough receiving inspection, this engine system was approved for Mercury and received the decal notifying all employees that it is to be handled with extra care. A total of 67 functional components and systems, ranging from engines to this gyro, are marked with decals when accepted for the program. The 67 are singled out for special attention, since each is to be kept under special surveillance throughout the production cycle. This surveillance will help assure the astronauts that the Atlas will do the job to which it is assigned. When a production employee sees this decal, it reminds him to handle that component with extra respect, to install it with special care, knowing that in addition to a vital national purpose, a man's life depends on its performance. The program for assuring high standard in parts selection and workmanship continues from receiving inspection through all manufacturing phases to final acceptance of the vehicle. Receiving inspections include this simple but practical shock test for transistors. The transistor must operate normally before, during, and after the instant of impact. In another typical inspection, sound is used to search for defects in metal. The sound is beamed through the test article, and its findings, which include flaws in the metal if they exist, are projected in patterns on a control console. The surveillance of materials and parts is performed by the Reliability and Quality Control Departments at Astronautics. Reliability establishes the standards for parts, which are then tested by the Quality Control Inspection Department. Reliability surveillance continues during assembly when parts are mated with components. Reliability engineers observe assembly operations to ensure top quality workmanship. If problems arise during this or any other manufacturing phase, the firm which made the part involved is contacted to assist in resolving the problem. Of course, strict quality standards are maintained at each manufacturing step in the buildup of all Atlas missiles, including the Mercury boosters. The vehicles are fabricated from rolls of thin-gauge stainless steel. The steel was inspected by its manufacturer, and again when it was received at Astronautics. Now it is inspected once again. A sample is cut from each 35 feet of every roll of steel and is subjected to tension tests to determine its strength. If it fails to meet specifications, the entire section from which it came is rejected. Each weld in the Mercury Atlas is also carefully inspected. A penetrating die is painted on the weld, joining these bulkhead gores. If the die should penetrate the seam, the work would be rejected. Finally, when the Mercury Atlas is completed, it is subjected to a series of final acceptance checkouts. Each of the subsystems is connected to specially developed factory checkout equipment for individual tests. Then all systems are tested concurrently in composite tests, which simulate the booster operation during a Mercury mission. The results of these tests are reviewed in minute detail by qualified specialists. As additional assurance that the Mercury Atlas has met the highest possible standard, a Special Air Force team meets with Convair engineers to review the test results and certify that the vehicle is acceptable. The quality assurance program has many phases, but reminding employees of their individual responsibility to the program is particularly stressed. Group lectures, training sessions, and this leaflet, which is available to all of you, outline the goals of the Manned Space program and emphasize your importance to it. The quality assurance program doesn't end when a Mercury Atlas is completed and leaves the plant. It follows the vehicle from the plant through the delivery stages and arrives with it at Cape Canaveral. All personnel at the Cape have been indoctrinated to the importance of Project Mercury, and they are carefully monitored to ensure maximum quality efforts at the testing complex. From the very start of development of a Mercury vehicle, from selection of parts and components to assembly of those parts into subsystems, and from installation and checkout of the vehicle to its testing at Cape Canaveral, a maximum effort must be made by all of us to ensure top quality workmanship and the best possible materials. Of course, it will not always be possible to know which components are going into Mercury. This is especially true for employees of firms which supply products to the prime contractors in the program. But you can be certain that some of your components, or the parts on which you work, are destined for Mercury. And the others, if they are for Atlas, will go into an ICBM which is now in operational use in the defense of our country. The need for maximum quality workmanship for both the Mercury booster and the Atlas ICBM is self-evident. And it is evident, too, that responsibility for the success of Project Mercury and the safety of the astronauts rests with us. Many of you met the astronauts when they visited Atlas production facilities. Remember that one day soon, one of these men will be aboard an Atlas Mercury vehicle, which you helped build. Build it so that after the flight, you can take pride in knowing that you were a vital part of the Mercury team.
Where do you start, Light? 25 seconds, Johnny. Minus 20.
Is that on the money?
20